All right. It's almost break for Thanksgiving here, so we're almost there. We're gonna do unit 13 today. We're gonna do two things. I'm gonna just talk and go over the reading on the next principle, interface segregation, and talk about that. I want to make sure I go over it because you might need it like for the quiz. I'll talk about that. Um, Hopefully you've been working on, we've been looking at this eShop app, and you were assigned different sections of the each shop app. And so second half of class, we'll go over and share those presentations for that here and see how those go. This is tied to last week's learning activity. So there are points assigned to it from the learning activity from last week. There really aren't any points for the actual presentation itself, but and so I think we'll have the presentation up here and we'll just probably just come up here, talk a little bit about it, and go around and see how that goes. It is important, I think, that you get some experience talking about technical concepts, especially with different audiences. And a lot of times those audiences might be business people or something like that, but it's good to be able to talk about technical things with other technical people. So people who are, I would say, peers to you in your knowledge level for that. So that's what the goal of this is to, well, two goals: learn more about the eShop app, and then also get some experience sharing that information. So that'll be the second half. There are no assignments this week and no learning activity this week. I've canceled, but there is the second and last quiz for this. So we have two 50-point quizzes in this class, and this is the second one of them. There isn't a final exam, there's a final project, so we will not have a final exam during the final exam period here. So they're just quizzes. So this is the second quiz. It's like the first one. There are 5 essay questions. You have 90 minutes. It's basically like a timed assignment in some ways. That's how I view it. A time review assignment. It's open book, open notes. You can use the computer, the web, AI, anything like that to help you with these answers. I'll just note, after I read 10, 15 of your responses, and I know some of you are knowing AI, and I have typed these things in AI. I know where AI gets these things wrong and where it gets things right and stuff like that. So if you're using AI, make sure you are carefully looking at the responses, because I'll know exactly where to look in the response to see if you corrected the AI's mistake in that response or not. So make sure you pay attention if you're using AI with this stuff. And again, we were just talking the other day. I think this is a good way to use AI. It's kind of like a co-author, co-pilot with this, where you can ask you questions, but you're just not. You're then using that as a rough draft or a starting point for what you want to say. Again, I know some of you may not have access to computers over break, so you don't have to do the quiz over Thanksgiving break. You have until not this Sunday, but the Sunday after that. So that's the Sunday after. It's 2 weeks. You have 2 weeks to do the quiz there, so you can do it. I'll just warn you, next week after Thanksgiving, we will have assignments and we will have learning activities. We'll have a normal week next week. So my assumption is that this week, when you don't have anything else to do, you'll want to do the quiz. But you may just have to collapse and rest over Thanksgiving. So if you need to do that, it's only 90 minutes. So there is a study guide here. I don't know if you don't really need to study for this because this is open book, quiz. But again, this just kind of highlights the reason we're doing the quiz is to force you to review mentally the topics we've covered so far. Yes, Hunter?
You said if we only use AI on this, we get roughly a week or so because you know where the AI would trip up.
Right.
what's the rough grade we'll get if we only use AI on this?
I think AI can easily get a B on this also. Right. Yeah. So if you just, like I say, there's a couple places where it goofs up, but it's there. And last one, I weighed it a little harder because I included more pictures in it and had you write that. This one, I don't have pictures in it so much. So I actually think it's a little easier to use AI. Although I do have like two places where you have to, I think I took out the YouTube video. Because it just didn't fit anymore. And so um I think it is just there's two places we have to read an external article and have it, but you can just paste that article in AI too now in that. So I think current AI will should be able to get a probably B plus on this quiz. But again, I'm not too concerned about the grade. I guess I am more concerned about your learning. I mean, and getting this stuff. So that's why like the study guide just kind of goes over the topics here that we want to be covering and stuff like that. So I'm more concerned about forcing you to just review these concepts here. So okay, so that's the quiz. Any other questions on the quiz? Let's look at integrate segregation here. So the poster for integrate segregation has a whole bunch of complicated interface here with lots of ports to plug into, and you just have one thing. And where do you want me to plug? Do you want me to plug this in where? Sort of idea. And that's kind of the idea of interface segregation is that our interfaces are getting too complicated, and we're going to simplify those for this. So I'm going to jump in the textbook here. I really like this principle because I think it's pretty straightforward. And I'm glad we're covering on this a short week. So basically, the principle is interfaces should be small. That is the whole principle. You don't want big interfaces with lots of stuff in them. We want small interfaces there. Now that we get down to a point where how small should they be? And some people like really small interfaces, but interfaces should be small, is the idea. And we'll try to look at that. So we're going to look at a big example with CRUD here. So again, CRUD is the common database interface. Create, read, update, and delete. And almost always when you're working with a database, when you're doing SQL or anything like that, any sort of persistent storage, you're creating records, you're reading records, you're updating records, and you're deleting records. So a common interface here is the CRUD interface. And again, it might not just be that, like this one has create, read one record, read all records, update, and delete a record for this. So here's our little interface on create, read, update, delete interface. Now this is a templated, well, I call it templated, type template or parameterized interface. So it's not just one type here. It says T entity, and we use T entity throughout this. So that this allows us to use the same interface if we have like an object that's a customer, and we can read and write and update and delete the customer record in the database, or if we have some other object like a product, we can read, write products or a medical record or whatever, it'll work for any entity, basically. And again, it's kind of interesting now. I just highlighted, we're now using these three kind of generic types here that I don't know if you were used to before, which makes, this kind of a weird thing. So we're using IEnumerable as our list. So when we read all, we get an IEnumerable list, a generic list from it. We're using this generic type or T entity. I'll just warn you, a lot of times when we write this, we just abbreviate with T. So often you'll see these interfaces with just a T for any type there. But here they're just calling it T entity, meaning any entity. And again, when we're reading one, we want to identify this, and we're using this generic user ID kind of thing that Microsoft provides, a GUID as a way of, it's like not a foreign key, a primary key into our records often. a unique ID for that. So that's our interface. Now we're going to look at some decorators to this, adding stuff. And the first ones are going to be what we call cross-cutting interfaces or decorators that apply to all of the interface. So one of them will be logging. So we could have a CRUD logging class. Again, it takes tender and it implements this interface. And it's going to be a decorator. So in the constructor, we're going to pass in a decorated CRUD, and then we're also going to pass in what we use for logging here, and we're going to store those both locally. I mean, this is just classic decorator sort of stuff. When we create, we're going to do the log, and then we're going to call the decorator to actually create. When we do the read one, again, we're going to log it and read one. When we read all, we're going to log it and we're going to read all here. When we update, we're going to log it and then call update. So all it is that just always logging it and then calling the corresponding CRUD activity in the decorator object. So again, it just wraps it around. And it's interesting, it affects all of the methods. Create, read one, read all, update, delete. Another way you could look at another cross-cutting example would be to do transactions. So again, sometimes when we're working with a database, we want to implement transactions so that we can roll things back, particularly. Now, this might be not a great example because it's very simple, but let's say our entity was more complicated in the way that we're data stored, where maybe we're working with customers and anytime we want to add or remove, we have to add a customer and maybe a customer family record and a, at least a primary address from the end to add. So maybe there's 3 tables we have to modify or something like that. There would be maybe a better example of a transaction thing here. But we're adding a class CRUD transaction. It's implementing this interface. We pass in the thing we're decorating, and then we're starting a transaction here. We're implementing the thing, and then we're saying the transaction's complete. And we do that with all of these things, where we're doing this within a transaction, and we can roll things back as needed here. And again, we're just doing one thing here. In real transactions, you'd probably be doing multiple things, like you'd add a customer and add a primary address record for that customer and maybe add a family, even a blank family record, for that customer or something like that here. But we do it for all things. So these are, again, what we call these cross-cutting concerns. And so we're saying, well, this is a wonderful interface. Well, I don't know why you'd want it any smaller than this. Works just fine. But now we're going to look at some examples where it doesn't work just fine. So there are some places where we'll want to add a decorator or something like that. And they're not going to be these cross-cutting concerns where that impacts everything. So for example, we just want to, whenever we ask the user, if we're going to delete a record, we want to prompt the user and verify that. So we want to add some check to that, some delete confirmation. So we're going to, and this is just going to be a decorator to delete confirmation. We're going to implement this whole CRUD interface here. And then when we do the delete, we're going to ask the user, are you sure you want to delete that? Read that in. And if it's correct, then we're going to do the delete. So that's the one change here. But it only affects the delete method here. But all the other ones are in the this CRUD interface. So we have to implement the create. So all we're doing is calling decorated create. And we have to implement read one. So we just have to call decorated read one here. Read all, decorated read all, update, decorated update. So all of these are what we call kind of fall through. What's the term they use? Pass through. That's what they use. Pass through ones.
Would implementing, say you wanted to ask for confirmation when you created an entity, would implementing the check for doing the same thing and asking confirmation if they want to create an entity, would you be able to do that without violating the single responsibility principle?
Yeah, you could. I mean, well, that's the question. It's how much, but often we'll think, CRUD might be enough of a thing to do that. And the question is, again, yeah, do you think of asking the user for verification as a generic thing, that a single thing, or asking delete permission, asking create permission? Are those two different things? And it's how you kind of envision it. So you can do it either way, I think, there. But the idea here is that we're only asking for delete in this example. And all these other ones are just pass-through examples here. So in order, it doesn't really make sense to have this big interface where we're just passing, we're not doing all of this stuff. So in order to fix that, we're going to move delete out into its own interface here. So we're going to have an I create read update, no D, no delete here. And then delete will be a separate interface. So I'll have two different interfaces here for now. And we're going to keep breaking this up. So right now we've broken it up into two. So again, here's our first small interface here, delete, I delete for this. So now when we implement this, our I delete confirmation just impacts the I delete interface. And that's the only thing. We don't have to have a bunch of pass-through objects here. And we're going to keep doing this, kind of following the same pattern. Well, let's say we want to do caching, and we're going to do a decorator for that. Caching only impacts when we're reading from the database. When you're reading one or more items from the database, you want to check if it's in the cache. If it's in the cache, read it from there. Otherwise, you're going to go out to the database to get that here. So we're going to have a caching, CRUD caching interface. Let's say it implements the whole I create read update stuff. It's going to not do create. It's going to do read one and read all. In those cases, we're going to check if it's cached. If it's not cached, we're going to read it from the decorated thing. Otherwise, we're going to return the cached entity and get the cache, read it from the cache here. But again, we still have these pass-through. Update just calls update here. So we have a method that just calls that same method in another object. Create just calls create here. So again, we have two pass-through ones, but we have to implement it because our interface requires us do create, read, update. So you can kind of see where we're going here. We're going to break this interface up even more here. So we're going to factor out two methods. We're going to have an I read interface here and another interface. So here's the I read interface is going to be read one and read all. So those are our two read methods. And now when we're doing caching, we can just implement the I read interface and update those two methods. And we don't need to have these other pass-through methods. And then we put the other methods in this I create update method. We have a create entity, update entity. And this is an area where the book says, well, those are very similar. Why would do we need two interfaces that basically say the same thing? Well, one, because to tell you the truth, in records, to create a new record is just updating it. I guess there's not that much. I mean, update looks to see if it's there and then creates it, or might delete it and create a new one often. There might not be an actual update here. It might be an actual delete and create. It might be in a create. But anyway, the textbook says, why don't we just make that a single I save interface where we just save this entity and we write this entity out there. So they talk about that. I don't really like that. I like the CRUD interface, but this is what the textbook does. And then they talk about some other examples like auditing. Whenever we save things, we want to do an audit here and updating that. So again, our interfaces we have an I save interface, an I read interface, where we have a read one, read all, and an I delete. So now our big CRUD interface is broken up into three smaller interfaces. And again, that's what interface segregation is breaking it up into smaller parts. And then we can write decorators just to decorate each different part of this. So, that's the basic idea of interfaces. Take a big interface, cut it down into a couple smaller interfaces that we can use here. Now they go over an example that talks about decorators and adapters together. I know some of you have been asking, what is the difference between, isn't a decorator and adapter exactly the same? One thing, here's what I often think of with the two. Let's look at a decorator first. So here's my version of a decorator. I get physical with these. So this is a USB-C plug there. So that's my interface is USB-C. This is a decorator that gives me an on-off switch for that USB-C. So it has USB-C and it has USB-C here. So I don't change it. This is USB-C. I'm decorating it. This is still USB-C, but now it's USB-C with an on-off button that I can click on-off here. So that's a decorator. It doesn't change the interface. It just adds functionality to that same interface for that. So I'm implementing the same interface here as here. I'm just adding some functionality. Now, an adapter, this to me is an adapter. When I look at, I have electricity coming in on the wall outlet, but I need to plug something in. I need to plug USB into that. It's different voltages here and a different configuration interface here. So, and I can't change the wall plug. That's pretty well fixed. I mean, I can, but it's a pain. So it's much easier rather than try to take out an outlet and put in a different outlet to just put in an adapter. So this adapts from this sort of electricity, 110 volt two prong to 5 volt, and this is alternating current, this is direct current. So again, it adapts, changes it. It's still electricity, still coming through, but this is adapting it. And so the interface here and the interface here are different. An adapter changes the interface for it. So that, just so we're clear on that going forward. So we're going to look at this example and a little bit where we're going to want to do event publishing and subscribing. This is what we've talked about a little bit recently with the eShop stuff, where we have we are looking at, again, when we're changing something, we're making an order, doing that rather than just calling or telling certain methods or certain other classes or projects, that we will publish an event here, and then we'll also have people subscribe to that event, to listen to that event. So this is what this is an event publisher and an event listener or subscriber listening to that event for this. And this is just a simple interface to these for this. And again, then we have like the delete event. So we have something that's implementing iDelete, but it's the delete event publisher here. So it implements iDelete here and will delete a record, but will also publish that information out for this stuff. So it implements the same interface, but adds this publishing information to how that works here. And so this, and then this also implements this other interface, this iEvent interface for this. So again, if we have these interfaces, small interfaces set up, we can kind of combine them in different ways and work with them. So like here is a modified version of this that implements both the iDelete and iSave interfaces. That's one of the things that's nice. Even though we have smaller interfaces, we can have one object implement multiple interfaces here. So this is implementing both the iDelete and the iSave interface. It is deleting stuff, and it is publishing that event. It is saving, and we have a decorator that saves it, and we're also publishing that event. So this is actually we've broken our interface up into parts, and now we're bringing it together kind of in a larger part. So this is actually implementing two of these interfaces together. So again, often when you're working with these interfaces, you kind of make them up into separate little parts and then decide if you want to combine, if you want one object to, again, kind of recombine and implement multiple interfaces here. So a single class can implement multiple decorators, or, you know, do the decorator on multiple interfaces for this. Let's look at some implementations for this, for back to our CRUD example now. We are looking at a generic type. Let's look at actual example of orders here. So here we're going to have multiple methods that implement the different features. So here's our order controller, and we're going to look at 3 different versions of this. This is the first one with multiple ones. So we're going to do an order controller. We're going to have orders. We're going to have a separate class for reading, saving, and deleting. A deleter, a saver, a reader here. So our and each one so we're going to pass those into our constructor here. We call our constructor, and we're giving it all 3 of these. We're giving it a reader, we're giving it a saver, and we're giving it a deleter. So we have separate objects for all 3 of these that we've created when we call this order creator. And then we just use those. So again, sometimes you'll have separate methods that'll implement each part of this interface, or separate classes that implement each part of this interface. And again, this did it with a particular order, a particular type. You can also do it in the generic sense here. And again, this is where you could see you'd use that, you'd create an order controller, and you'd pass in a reader, a saver, and a deleter. You'd pass in 3 separate objects for that. But you might have one big object that takes care of all of that database stuff. You might not have a separate reader, saver, and deleter. You just have all your database logic in one spot. So now we're going to look at a single implementation with a single instance here. So again, same sort of, we have a read, save, delete, but we have one object that implements all 3 of those. So here's our object that implements all 3 of those here. And now when we call the order controller, we create one of these generic data processing objects. When we call the order controller, we don't pass it. It knows how to be a reader, so we can pass it in as the reader. It knows how to be a saver, so we can pass it in that be a saver role. And it also knows how to delete objects. It knows how to do all the stuff. So we can create this order controller, and we can use this one object to do all 3 parts. So again, it's kind of like, I always think of it's kind of like when you do meal prep. You might take some stuff, you might cut it up into smaller parts, but then you combine it all together in the pan and cook it all as one big part in the pan. And that's what we're basically doing, is that our interface is saying, we can break this up into parts, and we're going to say, okay, we break that up into parts, but now we're still going to use this one big object to implement all 3 of those parts there. Why would you do this? Well, in the future, it would give you flexibility where if you wanted in the future to break this up or to decorate parts of this, you could. So you could decorate one part of this, and then you'd have a decorated part of this CRUD too, possibly here. So there are a couple reasons, here, but just so you know, even though our interfaces are small, we could still have one big object that implements. So again, this one big object implemented all 3 interfaces: the iRead, the iSave, the iDelete interface. So we can use it multiple times with our controller. Where again, the other one, let's go back to that one. We had multiple implementations. We had a separate reader, a separate saver, and a separate deleter. object here. And we define that. And then when we called it, let's go down here. When we created an order controller, we first created a reader, a saver, and a deleter and passed each one of those in to fulfill their roles for this. So that's where we have multiple objects. And then here with the single implementation, we have one big database processing object that does read, save, and delete. And so, but we can still use the same kind of structure. We can just pass that in as the reader, the saver, and the deleter. I don't know if that makes sense. It didn't make sense the first couple times I read this chapter. But I think it's really cool now. I had an assignment that lets you go do this, but I decided to delete that assignment because I found the assignment confused students more than it helped here. So I do suggest, I'm kind of going over this quickly. You might want, if this is confusing, you might want to just reread this section of the note of the book, because I think that the book does a pretty good job of explaining this. Okay, so we're just talking about, breaking things up and then combining all the ingredients into a big pot of messy stuff like a soup. And this is an anti-pattern. Here is, again, you might chop things up into small parts and then dump all these parts into a big soup of code, and it's still, you really don't get a lot of benefit. So there is an anti-pattern here, which we have to watch, where we are like building interfaces out of other interfaces, or creating, so this is an interface that we break the interfaces up and we now are combining them into another interface, which has the 3 interfaces in it and stuff like that. So there are some issues with how you want to break things up. So yeah, there's typical arguments with interfaces, and this idea is that it's similar to single responsibility pattern. What is a small enough block that if you make it too small, it gets confusing. You just have little interfaces all over there. So we're going to try to look at a couple reasons why you might. So we looked at decorators. That's one reason. Let's look at a couple other reasons why we could split up an interface here. So one is they're talking about the client needs here. So maybe the client will need you to do certain things. So like maybe the client needs, like, if it's a medical record and we're doing some auditing, maybe the client requires us to do certain auditing on certain database transactions. And so we'll want to separate those out into one interface so that we can audit those and separate the stuff that doesn't have to be audited in another interface or something like that. They go through an example with functionality. I'm just going to skip over that because I think the next example is better. So I'm just going to skip over this whole functionality example as another reason, and you're free to read that. I like this authorization example there. Let's say there are certain things someone can do when you're not logged into your system, and other things you have to be logged in. So I think we've all been into some app or some website or whatever, and you can do some basic things without being logged in as a user there. Maybe you can view the catalog, but you can't create an order. Maybe you can't even put things in a basket or something like that. Or you can, see what classes are offered, but you can't start registering for classes or something like that until you're registered, till you're logged in. So that's the idea, is that there are some things we can do without authorization, other things we have to be logged in to. So we're going to create 2 interfaces. One interface is the unauthorized interface here. Excuse me. And then when we can do that, we can log in, or we can ask for a password reminder be sent to us there. Login will then return an I-authorized object. And once we have that I-authorized object, or an object that implements I-authorized, then that will allow us to do things like change the password, add the basket, check out, or log out. But we can only do those things when we're inside this interface, or we're given an object that implements that interface. So again, when we start off, we're not authorized. Once we log in, it returns to us some sort of object, a user object or something like that, that implements this I authorized interface. And then we know that this stuff is only available under that once we're authorized here. So again, this is kind of functionality where we want some functionality to be allowed for unauthorized users. And once they're logged in, we'll be given an authorized object. And once we have that, this is the functionality that an authorized object can use. So again, I think sometimes when you're looking at how your functionality works, some things break down in interfaces well by kind of these sorts of features here. Here's another example of architectural need here. So that's not just features, but this is kind of like what other libraries are we using, or how is our structure, our whole architecture of our project. So like I say, high-level decisions can have a large impact on low-level organization in your code here. So let's say we have a database, a CRUD-like interface. We're just going to call it iPersist to write to the database here. Get all, get by ID, find by criteria, save and delete. So basically kind of a CRUD interface here for this. And here's our code to implement this interface here. So the yellow stuff is kind of generic stuff here, but you'll notice, well, maybe you won't notice. You're supposed to notice that there are two different architectures, database methods here. One is our main database, is our MongoDB database for doing stuff. So we have MongoDB database stuff, and that's in certain methods. So we pass in a MongoDB, and again, when we're reading from a database, we use that MongoDB. We're deserializing stuff here. Find by criteria also implements. So this green stuff, and where you see green is a MongoDB stuff here. Now the blue, this iSession, you may not know what iSession is, but iSession is from Hibernate, object database mapper sort of stuff. It's from nhibernate. So nhibernate is here and here for this stuff. So part of these things are using Hibernate and part of them aren't. So again, we're going to break down our interface into two parts, the parts that use Hibernate and the parts that use MongoDB, so that these parts that use MongoDB will only be dependent on that library and those features and tie to that database, where these that use Hibernate will only relate to this sort of stuff and Hibernate. So that's kind of the idea. This is an okay example. I don't know if it's the best example because you'll need an Hibernate to do this object relational mapping here, which makes sense. But underneath nhibernate has to be a database. I mean, it's an object relational database. It needs a relational database to map with. So it actually is going to also, I mean, it's got to tie back into MongoDB here. So this is an idea here, but I mean, in my mind, I'm thinking, well, that's great, but nhibernate also needs a backend database to it, which is probably MongoDB. So like this is MongoDB only, and this is like nhibernate with MongoDB. But I mean, it's an okay example. Again, so what they're basically trying to say is sometimes the architecture, what you're using in what places will dictate how you should divide up your interfaces in different ways for that. So again, the question always is that we have these big interfaces. How should we break them down into smaller interfaces here? So here's our iCommand and iQuery are two different, rather than one big CRUD interface, we're breaking it up into parts here. Okay, there's a bunch of other stuff. Another example here where I'm not going to go over it here. I'm going to show you one other quick video. This There's a video of the older version of the eShop on the web here. How's my volume here? So again, my question, this is actually came from I used to have students do this in the assignment, but because of Thanksgiving, we don't have an assignment this week. So the idea is watch this video and tell me if this person is going to implement the interface or not here. So yeah, why is everyone saying okay?
In my experience, most of the operations that you need to do in a typical business application are just fraud operations for the most part. Right? I need to edit this entity, I need to work with it, and when I'm done working with it, I need to save the changes. Right? If that's the 80% case of what you're doing, a generic repository like this works quite well. If you have a few places.
Okay, so the question is, this is an interface in eShop, at least the previous version of eShop. Does this implement the interface segregation principle or not? And the idea is that, so it's one interface, async repository, so asynchronous database writing. It has get by ID, list all, list one, or add, update, delete, count, first or default here based on some specification, some search criteria in here for this. And again, now maybe one of the problems, we get it is, does this code make any sense at all to you? So now you're kind of thinking I interface, this is an interface. T, these are these templates, so it works with any kind of object. And again, our example in the book was a T entity. This is just T here. So again, we can pass in, we can do an async repository for our products or our customers or anything here. And this task and all these words async. So again, they're doing this async and they're not returning an object T, they're returning that surrounded by a task. And remember, that's like a future in Java. It's not, eventually once the async operation will get done, once we finish this up, it will just be this object here. It's interesting, they're not returning IEnumerable, they're returning an I read-only list. So I thought that's what IEnumerable was, basically. So I don't know why they're returning an I read-only list rather than IEnumerable here. But again, hopefully you can kind of look through this code and make some sense of what it's trying to do here. And the idea is that this is a big interface. This is not implementing interface segregation very well. This is a big interface, big complex interface here. Probably not following that principle very well. It's all database stuff, but again, it's still a lot of database stuff here in one interface. So doesn't follow our principle very well. I think I'm going to wrap up here and let's jump into the eShop presentations. So I think that this is the hardest type of stuff for software developers. I struggle more with this than anything else. This trying to look at a code base and figure out what that code base does there. So my goal in this assignment was to make you feel that this was hard to do and that this is difficult there and challenge you there, because I think, and again, we've asked a couple of our guest speakers, and they've talked about the same thing. It's challenging when you're jumping into a new code base or a new area to try to figure out what that is doing there. And so I think looking at an object like this is good. I mean, it's challenging and it's good to practice this. And so much time in this class, in our whole curriculum, we look at really small little projects. Even our big projects are really, I mean, if I look at our mobile apps class, even our most complicated mobile app is very simple compared to what a real mobile app looks like here. And so that's one of the goals here is to do this. Originally, our book that we worked with, I think got rid of the book. Okay, the book we did had a bigger project with, but that project got out of date, and I don't even think it's in the current book there. But so that's why I've swapped to this project as a good example here. So hopefully we've got some slides here. I meant to replace the pictures in that, but I didn't get a chance. So we still have our fun pictures for this. So why don't we go through this and share this stuff. So I think again, we just want you to go here and tell something about your area and what you worked on for this. So each area, hopefully, again, I don't know if I know a number of you found that these didn't all fit, which is great. I'm hoping an overview, the main parts, if you had some data models or information, and inputs and outputs for this. So those are the 4 parts to each of these. So let's see if don't see Sumner or Baum here today for this stuff. So let's look through. I'm wondering, I told them they could do, I'm going to jump. Did anyone try to add dictations to these? Because I thought you could, but I don't know where. I didn't look to see how you did that. Okay, there. Okay, so those are. Okay, so there's speaker notes. Let's see if we have any speaker notes up here. We've got those now. Okay. No, I'm not seeing any speaker notes. Okay. So again, we're ordering. So the basket is just a microservice that gives us the shopping basket, right? That's all it does. It again utilizes this asynchronous event-based communications for this. Yeah, so we use this URL stuff. The database it uses is this Redis database, and it's running in a Docker container like most of the other things. Here we have an API gateway for this. So I guess we're getting things. Yeah, so I'm wondering where the basket is. I thought the basket got things. We accessed the catalog, and I thought we accessed the order also. We subscribe to events when the prices change through Rabbit MQ there. And our outputs, our order date and our basket information and the zip codes. So, okay, let's go on to catalog. Rylan, Omar, both of you want to share up here? Yeah, it's right there. There, up there. Yeah.
Do you mind, like switching slides?
Oh, yeah, sure. Should I make a slideshow?
It doesn't matter.
So we were investigating the catalog.api. So the catalog API is a data-driven / CRUD microservice, and it manages pretty much all the information about all the products. And it stores that information in a SQL Server database, which is then deployed as another container. It also leverages Entity Framework Core, which that is spelled wrong, as an relational mapper to kind of interact with the database. And it also integrates Swagger to provide API documentation and integration with other tools. And just overall, the API is designed to for a containerized environment, and its configuration is managed through Docker Compose files to allow it to easily be deployed and scaled.
The catalog API uses a well-organized data model to manage product information. The main entities include catalog item, which stores details like the product name, price, and stock, as well as catalog brand, catalog type, which helps organize the products. To handle its database interactions, it uses a repository pattern. This design manages the code easier to maintain and allow the developers to test components without relying on the database directly. Finally, the API controller provides the endpoints for performing CRUD operations. For example, the client can send GET requests and retrieve products and post requests to add new ones.
So then the catalog API stores a variety of different kinds of data. It mainly stores information related to like the products. So it'll store product name, descriptions, prices, and images. All this data is managed through a SQL Server database, which is typically run within a Docker container. It also uses Entity Framework Core for data access, which is a lightweight object relational mapper to interact with the SQL database. And it uses data seeding to provide initial data for demonstration and testing. So just kind of like basic data to be used to test and make sure everything's working. And then the core of the catalog API's data model is the catalog item entity class, like you mentioned, which represents an individual product in the catalog and displays the information stored. And then the data retrieval from the database is accomplished by using LI/NQ queries executed against the Entity Framework Core to sort, filter, and paginate data as required.
Catalog API manages key products details like names, descriptions, prices, and stock. All this data is stored in the SQL Server database and starts with sample entries from a catalog JSON file for testing purposes. The clients interact with the services using HTTP requests. GET is used to retrieve product data, post to add new products, put to update them, and delete to remove items. For security, Catalog API uses JSON Web Tokens or JWT to authenticate users. Authorization ensures that only users with correct permission can modify or access specific resources.
And then with the outputs, obviously the outputs detailed are going to be mostly product information. So all the details on individual products, such as the product ID, the name, description, price, picture, file name, picture URI, catalog type ID, catalog brand ID, available stock, restock threshold, max stock threshold, and the on reorder status. So basically all the information that you would need to catalog and make sure that you have all the items in store and then what those items are. And then it also paginates lists of products. So basically to support browsing and filtering, the API outputs sends lists of products that include the current page index, page size, total number of items, and lists of catalog item objects, so that when you go from page to page, you know everything that's on there. And then the catalog data for shopping baskets. So the information that's in the shopping basket microservice, including the product ID, the name, and the price, So it outputs that information. And then it also outputs the like responses to any data modification requests. So as you mentioned, if they're authorized to edit the catalog, then it'll provide responses for requests for creating, updating, or deleting products, which will show whether it's a success or a failure. And then if needed, it'll display the error message if there is a failure. And then also outputs the API documentation. So using Swagger to provide comprehensive API documentation, including available endpoints, the request and response models, example values, and error codes. And then lastly, it outputs the health check status. So basically it'll check to make sure that the catalog API is healthy or unhealthy, and then display the status of that as well as its dependencies, depending.
Great.
Just a quick note as we're doing this. One of the reasons we want to dive into this is that for the final project, so after Thanksgiving, we'll have 2 weeks of class, and we're basically, I mean, well, we have a little bit, another 2 chapters we'll do, but a lot, you won't have much in the way of assignments. Instead, you'll be working on this final project. And a lot of the final project, the main option here is we'll do a sample sprint on eShop here. So you'll be given a list of user stories with story points attached. And your idea is that you're going a 2-week sprint here, and you've got to do enough story points. There'll be so many story points you have to implement to get a passing grade on the project. And so like there'll be some pretty common tasks here. One of them will be to add a new attribute to the catalog. So I forget which one it is. So like right now we have like you were saying, a picture, the price, the name, the description of a product. You'll be asked like to say like what country origin or something like that to a product also, and we'll want to display that. And the question is, how do you add that to the database, to the order stuff, and then display it on the catalog page or not there, and we'll talk about that. So again, we'll leave this open so you can return back to this. So hopefully you can look back at some of this catalog information. So if you're going to be doing that, hopefully that'll help here. Okay, let's go on and do identity.
So identity API, this is just used for authorizing access and for authentication for any users who want to access the secure microservices. So it also issues tokens, it generates tokens that are used by users to access the secure microservice. And the key parts of the identity API include the user information storage and the authentication mechanisms. And it uses the ASP.NET Core Identity for user management and an OpenID Connect and OAuth 2.0 provider to issue security tokens. And it also has a standard endpoints like the connect /token for programmatic token requests. And then the data that is used, the identity API references data that is related to the user identities, the user roles, and the user claims. And this is also stored in the core identities entity framework. And the API also references the client and API resource definitions, which determine the resources that users can access with their tokens. And the inputs into the identity API, since it's used to authenticate users and to allow access into the secure microservices, it takes the user credentials, right? Like the username, the password, and this is used to compare with what is stored in the data storages, such as the ASP.NET Core identity. And it also takes external authentication tokens, which have external providers like Google, Facebook, and companies like that. And these tokens are used to authenticate the user and also associate those identities with core identity. So ASP.NET Core identity is what we're using to compare whatever the input is, whether it's an external authentication token or a user credential. And you also have token requests and token validation requests, which the ones that other microservices can send requests to the identity API to validate security tokens they have received. And then on outputs, this identity API can also output security tokens, and these are issued to the authenticated users. Since we say that it generates tokens, so these tokens can be given to users, and this contain claims about the security principle, include their identity and any other information that can be used to determine the level of access to grants. So, for example, like if you want to access the system, you may not have the same level of access compared to another person. So it will only allow you to access to a certain level, which fits with what you have been assigned to according to the API identity core framework. And it also provide endpoints for other microservices to retrieve user information based on provided security token, because it has information about users. So it can also output their information based on the tokens that are provided by the end user or the client. And it also outputs authentication results. These are the results of authentication attempts to the requesting client. This indicates whether the authentication was successful. If so, it might include about the authenticated user, or like say, oh, you have not been given access, or maybe you are not allowed to. Maybe it's a token that has been used before. It might say, oh, this token has been used before. This token has expired, or you have access, all things like that. And then validation results. In response to token validation request, the identity API would return information about the validity of the token. This is what I was just saying. This could include whether the token is valid, its expiration time, and other relevant details. For example, maybe you have access, but this access is limited for a specific time. And then it will be like, oh, you have access. But this token is only valid for the next 1 hour or something like that. So yeah, that's all about identity API. Thank you.
It's interesting, hopefully we can start seeing how some of this stuff is related to, like, we already learned that in the catalog, you needed an identity token to, not to view the catalog, but to add items to the catalog there. So there's some things that are restricted that you need an identity for. Now we're, I'm going, well, what was identity token? And now we can see hopefully that identity token there. So, okay. Michael, Hunter, you want to go from here?
So we have the ordering API. It's a reference.net application for the e-commerce website, using a simplified command query responsibility segregation approach, which means that it has two logical models, but one database. The one logical model is for handling queries, and then the other one is up for handling.
There are multiple different parts to the ordering API. There's an application layer, which is kind of the entry point for external interactions. It's responsible for receiving commands, processing commands.
Close the door with that hammering out there.
Yeah. Like, and then like persisting like any state changes or using the transactions. Kind of acts as a coordinator, delegating the work. Kind of all of that stuff. The domain model layer is kind of the heart of the ordering API. It contains the kind of the core business logic and the rules related to the ordering process. So it contains a lot of different things like domain entities, value objects, domain events, kind of all of these things. The infrastructure layer handles the technical details, and is kind of responsible for implementing the repository contracts defined in the domain model layer, managing the database interactions, and then it also has queries for like read operations. It uses simplified queries with Dapper, which is a micro or ORM. Yeah.
Yeah, and kind of building off of that for the database, has a data, as mentioned earlier, single database, two logical models, data persistence in its transactional area, when it's handling updates, make sure that that data persists up into the database. And yeah, it uses Dapper, which is a micro object relational manager, allows for efficient and flexible querying. It also allows for plain SQL statements to be performed without restrictions like other patterns. Uses an aggregate and repository pattern, which abstracts data persistence logic from the domain model, which allows for cleaner separation of concerns, and explicitly configures how domain entities are mapped to the database using the on-model creating method of the ORM. Going into the inputs, they aren't clearly stated, but there are like commands that are allowed as inputs. Accepts commands from client applications, such as web or mobile apps to initiate operations related to order processing. And this is the create order or update order or to cancel order. They're typically transmitted as HTTP requests, which routes it to the specific microservice. It also receives integration events from other microservices through the events subscriber. And again, for like retrieving data. Yeah, that's pretty much, I think. Oh, and then the authentication using the identity API to ensure that there's access to what you're trying to do for that order.
This one. So with the outputs, obviously it outputs the request results that it gets with the commands, along with any error messages that it might encounter if an error occurs. That kind of thing. It also like will return view models with the data from queries if it's kind of thing like it's suited for the client's needs. That kind of thing. It'll also kind of it'll publish integration events to the event bus to kind of notify all the other microservices of any changes related with the ordering process. And then it also does like it'll update, it'll reflect changes as it says in the databases. And it'll just log information with the telemetry data to kind of provide insights of what the operation's doing.
One thing kind of that, well, two things that are interesting with this system is that we just talked about ordering and and we talked about the basket. And so there's products in the, I mean, we talk about the catalog. So there's products in the catalog and there's products in an order. And probably like in a database management class, you're thinking one big database and you'd have a foreign key. Your order would just have a key for each product in the thing. But in reality, in real apps like this, we don't do that. There's two separate databases because again, they're running microservices, but also so when you order something, we're copying the data from the catalog into an order item generally and setting that up there because something might be removed from the catalog or edited from the catalog. So like, like if you go to e-commerce stuff, you can look at something you ordered 2 or 3 years ago, even though they might not still be selling that, but they still have that information about, it might have been a different quantity, a different description or whatever. But when they keep track of exactly what it was when you ordered it there. And that's the same thing here. Another thing we've already seen is a couple different kinds of databases, Redis and SQL, SQL Server. And again, maybe this one was using Dapper. And it's one of the interesting things here. This is a reference app. So Microsoft is trying to show all, in ordering, they're saying, well, someone might want to use Dapper with an SQL Server and do it this way. And then in this microservice, we're going to do something entirely different. Normally, you would not do that. You would probably want to use the same database technology across all your different areas so that when you learn one, you would know how it works in the other ones. But that's generally not how it works here. Every separate microservice often runs a different kind of structure to the database. So watch that as we go forward. Okay, let's talk order processor related to this. David Briston.
Okay.
So far, my favorite has been who updated the graphics, the catalog graphic. That was really nice. Someone updated the catalog graphic. Yeah.
Images in, but I saw everybody else's was the same, like, oh, I don't know how
Yeah.
allowed to
So I
do
like
that.
catalog image updates.
I changed my profile, so.
Okay.
So the order processor and its component parts are defined exclusively to handle processes related to completing orders, which could include the retrieval of grace periods and checks for updates. The parts were broken into 4 folders in the actual software. There was a services folder, an events folder, an extensions folder, and a properties folder. The services folder contained the grace period manager service, which takes in 3 interfaces as parameters and implements the background service. The grace period confirmed integration event creates confirmation records with the order ID. There are 2 objects within the extensions, an event bus and an ordering database. And then the launch settings JSON is stored in the properties, which includes the port that acts as a listener for the API. I was able to, as Tom said, this is difficult to do. So I was able to define an order ID as some of the data that's being passed around. And then I saw the grace period value as an important event, as a piece of data related to events, because as far as I understand it, the grace period allows the user to correct any mistakes made in the order before any payment is finalized. So the grace period is kind of an important thing in any kind of order processing.
So the inputs of the order processor, first we have HTTP requests from the clients. These come in 2 forms. First is queries which are used to retrieve data without making any changes to the system. For example, a query might be something like get my order history. And then there are commands which are used to perform actions that modify the system in examples. An example is a create order command, which is used to create a new order. And then next we have integrated events, which are triggered by other service. A key example is the user checkout accepted integration event. This event is held after a user checks out their shopping cart and the order process lists it through RabbitMQ or event bus, which also relies on configuration settings such as grace period time and check update time. These settings help define the timing rules for process orders, and they are loaded via dependency injection. Lastly, we have database inputs where the order processor queries the database for orders that are in specific states, like orders that have been submitted but are beyond the grace period. And then why is this important? These inputs make sure that systems can respond to user actions like creating orders and also react to external triggers like database events from other services. And then the outputs of the order processor, the first type of order output is HTTP requests to clients. These are the results of queries formatted as DTOs or view models, such as the order summary view model. For example, the client might receive a response with update order details or the status of their order. The second type of input is published integration events. These events notify other systems about changes. And a great example is the order status change to submit integration event, which is sent out to services like inventory or shopping to let know the order is ready for processing. Next, we have database commands processed by the order processor will save our update creating orders and relate entities in the database. For example, a new order item entry might be created or an order status might be updated to completed. We also have logging and monitoring, which logs actions like publishing events and updating the database. This is very important for debugging and tracking the flow of the order processing. And then lastly, why is this important? These outputs help keep other systems like inventory and shipping in sync with us, also ensuring that the database is accurate and up to date. This contributes to smooth operation and overall data integrity.
Right? Thank you. Now, one area where I think you mentioned dependency injection here, and that's one thing we haven't really talked about. What makes this code really hard to understand going forward. And so that's one of our last principles, and we'll talk about that a little bit later and try to figure out. But that is just how objects are automatically created to fulfill interfaces there. And it's very confusing in these systems how that works, unfortunately. So, all right. Grace, you want to talk about order domain and order infrastructure? We've been doing lots of stuff on orders, so let's see.
So order.domain encapsulates the core business logic of the ordering microservice, ensuring all processes like adding items, validating data, and calculating totals align with the domain-driven design principles. On the other hand, order.infrastructure handles data persistence, bridging the domain logic with databases through repository patterns and tools like Entity Framework Core, ensuring seamless data storage and retrieval while adhering to the domain model. Order.domain is a business-focused layer and contains the core business logic. The order.infrastructure layer deals with the how of data persistence and implements technical concerns and external integrations while not containing any domain-specific logic. The separation of the two allows for better testability, maintainability, and evolution as you can develop them independently. Order.domain represents core business concepts again and infrastructure, data manages persistent models, repository implementations, external integrations, and event handling focused on how data is stored, accessed, and interacted with externally. And the data flow looks something like this. When a command like create order command is received, the corresponding command handler in the application layer uses the order repository to create a new order, aggregate, and memory. The aggregate root enforces business logic and ensures data consistency. The repository then uses the DB context to persist the order aggregate and its related entities to the database. This separation keeps the domain model focused on business rules and free from infrastructure concerns. For the inputs of order.domain, it includes user commands or actions that represent business operations, data transfer objects, events like order placed and order canceled, and entities and aggregates. Order.infrastructure layer inputs include data access requests from the domain layer through repository methods, like, for example, saving or retrieving entities like order. Database models, external service inputs like API requests, domain events, and command and query handler inputs from the application layer. Order.domain layer outputs include domain events like order placed and order canceled, updated domain entities, calculated results, and errors or exceptions due to business rule violations. Order.infrastructure layer outputs include persisted data like order entity being saved in a database, responses like success or failure from external services like a payment gateway, database models or entities, event handler outputs, and error responses or failure states in case of external or internal issues.
Thank you. Okay, while we have, I want to watch our time here, so while we have Johnny, Jeff, let's go ahead and talk about webhook. One thing that's interesting, I think, we mentioned the different things, and so like the baskets and catalog, I think the domain, there's a domain folder with the database, kind of structure inside the baskets, inside or catalog. But like when you get this ordering, it's a more complicated system. So like a domain is separated from order processing. Okay.
So we had the webhook.api. So a webhook is an HTTP request that's triggered by an event in a source system and sent to a destination system, often with a payload of data. They're also automated, which means that they're automatically sent out when their event is fired in the system.
The webhook API contains interfaces such as iWebhook Sender and iWebhook Retriever, which each run their specific tasks respectively. The webhook sender, for example, runs a task that actually sends the webhook data, and the webhook retriever class runs a task that gets the webhook subscriptions. Webhooks.client contains a webhook.received class that keeps track of when the webhook was received by the client and the data contained in the webhook. It also contains a webhook response class that stores the data the response was created and the URL where the webhook is being sent.
A webhook API and client typically deal with event-driven data, meaning that data that represents an event or state change in the system that generates the webhook. The exact type of data that's being dealt with the webhooks varies based on use case, but typically it's in JSON or XML format.
Some of the inputs of the webhook API and client is date time. It'll keep track of when the webhook was created or received. URL endpoint is the URL to which the webhook request is sent. The payload, which is the actual data to be sent in the request, typically in a JSON format or XML. Event type or name is included to specify what kind of data or event is being communicated. And a token is used which is used for the authentication or verification purposes to ensure the request comes from a trusted source.
For outputs are generated by the webhook API when the event occurs. The components of a webhook output usually include the HTTP request structure, headers, and a payload. The request structure contains a method and an endpoint URL. The headers indicate the format of the payload and identify the service, and the payload is often in a JSON or XML format, contains event metadata and data objects.
Thank you. I want to talk about how we pay for all this and stuff.
So payment processor. The payment processor is a key part of the eShop project. It is responsible for handling payment-related tasks like processing transactions and ensuring secure communication with payment gateways. This component ensures the system can manage payments smoothly and integrates with external services. It uses RabbitMQ for message handling, making it work in a distributed architecture. The payment processor is designed to be modular so it can adapt to different payment gateways, ensuring flexibility for the eShop system. It simplifies payment workflows and ensures they are reliable and efficient. So the payment processor, section 2 is the parts. So message queue, gateway abstraction, transaction handling, error logging, and configural setup. And then the data it has is transaction details, customer information, payment status, error logs, and integration data. The payment processor receives several key inputs to perform its functions effectively. It processes transaction requests that include the amount of currency and payment method details. Customer information such as customer ID, email, and payment preferences are also essential for ensuring smooth and personalized payment experiences. Additionally, the component relies on secure payment gateway credentials like API keys and authentication tokens to interact with external services. Inputs from RabbitMQ in the form of payment-related messages trigger the processing workflows. In case of issues, it also accepts commands for error handling, such as retrying or canceling failed transactions. The payment processor generates several outputs as parts of its operation. It includes transaction confirmations that include details like payment status, successful, pending, or failed, and relevant timestamps. For failed transactions, it outputs error logs, which help in debugging and ensuring transparency. Notifications are also sent to other system components or external services, informing them about the payment outcome. Additionally, it provides updated customer data reflecting payment history or preferences. These outputs ensure smooth communication between services and maintain the integrity of the payment workflow.
All right, thank you. You ready to go?
Since we don't have too much time, I'll be very quick about it. So our topic is eShop app host. Is it very quick overview? That's like the main part of this web app because it's
That's
basically
why we gave it to you. It's the whole thing, it's the front end.
Sure.
It's it.
So if you open it in the actual Visual Studio Code, you will see it's not much stuff inside, but that's actual the less it has, the most important it is, like always in life. So basically what is that? We have a lot of microservices and like the data SQL stuff and like some web application and some user inputs when we receive like from the actual like web page. So this is like the middle part of everything. It connects like microservices to our user, to database. So it's like if you imagine like a web, like the spider create, you have a lot of, and the actual spider is inside. So this is actual eShop app host. I mean, I kind of we with my partner kind of diving in the some details like what is the use, how it connects, but basically, yeah, the only you should know that it's like connects everything.
Yeah. I can dive into like some of the parts that are specified here. So there's like the central coordination, which is serves as the primary was coordinating all the microservices and managing the application's lifecycle. There's also the infrastructure integration, which factors in things like SQL for the database, Redis, RabbitMQ, and also things for like messaging, caching, data storage, and it also has AI capabilities. It also has microservices connectivity for the identity, catalog, ordering, basket, payment, and webhooks so that there's seamless communication and functionality. There's also client app support via mobile apps and web apps for user-facing operations. And also the cool thing about this thing is that there's also like scalability and modularity. So it's easier to like, allow new features or to like, expand these operations. So
Yeah. So the data, basically we have everything that we need for the whole app in this, all kind of like this server, I would say that is responsible for that. So these servers contain, like if you see in the code, actually there's like item root hashtag. So it contains every connection for every microservice we have. Like for example, if you would order an API. So basically it contains a link, like the reference to our ordering microservices that kind of like, because it contains API, so we kind of have everything in this app. Like we have, I don't know, mobile.bff.shopping something. So basically it contains reference to our mobile like microservices that trigger when user from his or your mobile app like order something or put something in the basket. So yeah, we have every information about infrastructures like data SQL that we have from database or from like Docker or Azure, which is cloud. Like yeah, some connections to API features. So basically everything, yeah, again. Oh yeah, we have security credentials. You can see it in the user secret ID hashtag. As I understood it, I think we have everything for every user, we have unique ID. So I guess we just did it here, kind of one user for everybody, right? Secrets ID user.
The demo app, there's two users
Okay.
that are only available.
And they have probably the same user secrets ID, right?
Yeah.
Yeah, because we basically, yeah. So that's contains the most important like information about the user, like I guess in the future apps it will be like card information or like products you purchase already, like history of all purchases and everything. I mean, yeah, we have when user did something, of course it triggered microservices, so we have this information too.
We're gonna have to wrap you up, I think.
Sure, okay.
Anything else?
I mean, basically, so inputs, we received any information for databases or like from user. Outputs, based what our microservice do, we received outputs and user information. So yeah.
Okay, good. Thank you.
All right.
Okay, so our main part is the integration event log, e-app, and eShop service defaults. And a little bit of overview about that is that it helps ensure that when a microservice updates data, the event is reliably published to other services. It also uses special integration event table in the database to track events and their status. Another thing I also wanted to mention is that it ensures atomicity, I think, meaning both the data updates and the event login happen together or not at all. If an event can be published right away, it says in the log and gets retried later. So that's also an example here. So if the price is updated, the catalog microservice updates the product data and simultaneously creates an event called product service change integration events. And if it fails to publish, it will just stay in the log with the status like ready to publish. So the parts of this project were integration event table that stores event details like ID, type, and status, integration event log context, integration event log service, resilient transaction class. An example for that was if a product price is updated again, the event is saved and marked publish once it's sent to the event bus.
Okay, and then a little bit of our data. We had 4 main elements: event ID, event type, event data, and state. And little bit of explanation. Event IDs uniquely identifies the event for tracking and deduplication. There's also event type that helps subscriber identify the event. Then while the event data often serialized as JSON contains the relevant changes or updates. And there's also integration event log context and integration event log service, which are a mechanism for the schema evolution that ensures reliable processing and future flexibility.
All right, so some inputs for the integration event log EF and the eShop service defaults. So for the integration event log, so it uses Microsoft Entity Framework Core, which provides ORM capabilities, which handle queries and event logs. And we use a system data SQL client, which manages communication with SQL databases. And then we have an event bus package, which tracks the status of events that are published or failed. And then for the eShop service defaults, we have an ASP.NET core web framework, which configures default service behaviors such as logging and health checks. Configuration packages handles app settings and environment-based configurations. And then we have resilience packages, which implements retry policies for HTTP calls. And then for the outputs, we have an event bus package, which publishes integration events to external messages brokers for inter-service communication. For the database, we writes integration events to the log table for reliable message delivery and transaction consistency. For monitoring tools, sends logs related to event publishing for monitoring and diagnostics. And then for the eShop service defaults, we have external APIs which send HTTP requests to other microservices or APIs. And then this one also has a resilience and retry logs, which outputs information logging systems about retries or circuit breaker activations. And lastly, it has consumers of REST APIs, which outputs API responses to consumers.
Thank you. Last one today, I think, is up for the online people.
So we had the event bus and event bus rabbit MQ. So an event bus is a system or software pattern that facilitates the communication between different components of an application by transmitting events. And the event bus rabbit MQ is basically the same thing, it's just a more specific implementation of the event bus pattern.
Okay, so for the event bus, what is happening is that with the publisher, so when you get when you register for the system, right? With your information go to the publisher, but it should go to the subscriber so that it can pop up to the front end. So that is what the event bus is trying to do. It is just trying to take a message or an event from the publisher to the subscriber. So between the publisher and the subscriber, there's an event bus interface, which just helps to let's say when you write from publisher, that can take the names or the entities that can help with the entities to be entered in the interface. Then so when it goes to the when it is now going into the subscriber, right? There's also what they call an event dispatcher, right? So this helps to make sure that it goes into the correct subscribers from the publishers. So that is all. Let's say so that is all when you create an account. Then the second one is also another pattern that is just similar to the event bus rabbit. This one, it just uses the rabbit MQ, which is just another way of sending them, of transmitting the message. So here on this one, we have the exchange. So the exchange is just something that we is just the way of sending this message to the queue. So we have we're trying to send the message
from the process something to the queue so that it can pop up to something like, oh, okay, a payment processed or something from the system, that's something from somewhere where the process happens. So during this process from the extent to the queue, what happens is that there's a binding in the middle. It's just like acting like an interface, you know. For this one, the binding will determine like which message should go to the certain queue, you know, like let's say your payment process is to order 1, 2. So this one determines like which message should go to the exact queue to be processed, and this is helped by the routine key. Routine key is a label on the message that is like, oh, this message is for payment processing. So when it goes to the binding, it's easily go to the correct queue easily. So, and we also have this customer. So the customer is like the friend that received like the server that received like the message, the messages from the queue. So like your payment processed, or you know, your order is now like your cart is now saying 2 or 3. So that is all. The other one is just as checked out, which is just like where these things happen, the message broken and channel and connection.
As for the inputs, the input to an event bus typically consists of event messages, and that typically contains event type, timestamp, payload, and the metadata. And then that would be kind of the same thing for the event bus rabbit MQ input. And then finally for the output, since they don't have any like designed return values, they just like have like triggered actions or state changes and cascading events and like send out those messages. That's all we have.
Okay, thank you. So for the online students, let me check, make sure the online students are online. All right. Bethany did stuff on the mobile front end, and again, you can read through her notes here. We don't have time to go over those today. And then Nora and Lonnie did the web front end and went through those. And again, when you look at this, you can see their notes here. You might particularly want to do that if when you're working on the final project and you need to make modifications to those, you might want to refer to those. Those are done well. All right. Thanks for coming here. Hope you have a good break.